Good morning, everybody. I'm not here today, so I was going to do a YouTube lesson. Hope you guys enjoy it. At the end of last week, we started to look into the similarity of right triangles and how you can take a big right triangle, draw the altitude to its right angle, and you end up with two smaller but similar triangles to our original one. Since they're similar to the original one, they're also similar to each other through the transitive property. Okay? And since we now have three similar triangles, we can go ahead and start looking at ratios between those triangles. But those ratios are important to kind of compare proper sides. In all three triangles, all three similar triangles, you've got to compare the hypotenuse in each one, the corresponding side. You can't compare the hypotenuse here to the long side here. It's not going to work. Got to compare the hypotenuse to the longer side, or to the other hypotenuses. We compare the long legs, and we compare the short legs. Okay? And so in doing so, we can create ratios depending on what triangles we want to compare. Now, depending on the class, I went through the problem a little bit differently with each of you. So we're going to talk about those and talk about how to go through these problems one by one. But you want to start to get the hang of it and then just go ahead and do it yourself. So let's talk about this first problem here. Here, we knew that this length was 20. Now, depending on the triangle, we looked at different specific lengths. Okay? So in this triangle, we have the hypotenuse is 20, and then we've got the long leg here. And in this small triangle, we have a hypotenuse that's 15, and the short leg is 9. And I think in this triangle, I said the long leg, this is the short leg. And so that allows us to create a ratio, hypotenuse to hypotenuse, and I actually used the wrong color here. Let's go ahead and make that color correct. Hypotenuse to hypotenuse. Oh no, that was right. I don't know what I was thinking. Sorry. I meant hypotenuse, the pink one, to the hypotenuse. And so we can compare 20 and 15, and that's what happened here. Then we want to compare the short legs. Short leg here is 9, and the short leg here is going to be something. We want to find out what it is. Since the ratios are the same, we can go ahead and realize that that one's 12. 9/12 is the same as 15/20. Another way to do it is to actually write this out and then to solve. So I'm going to write it out. We've got 15 over 20. That's equal to 9 over h. Now, how do I solve for h? Well, h is in the denominator, so the first thing I want to do is multiply by h. I'll cancel it out and get it in the numerator over there. And then I'm going to want to first rewrite it. H times 15/20 is equal to 9. And then I need to get rid of that 15/20, so I'm going to multiply by the reciprocal. 20 out of 15. 15 cancels, 20 cancels, and we do the same thing over here, 20 and 15. So I end up with h is equal to 9 times 20/15. Okay, if you go ahead and plug that into a calculator, you'll get h is equal to 12. And we're all set. But it's also an easy way that you can do it is to look at these comparisons and think, oh, 15 and 20, that simplifies down to 3/4. And that would be our scale factor from the medium to the small triangle. And then use that to find out what the long side is. There's multiple ways to do this, but what I want you to do, and the biggest thing, is to create the proper ratios. You can't solve an equation well unless you have the proper ratio to begin with. So you want to create the proper ratio, and then we're going to solve that ratio. Okay, and you're going to solve it, and then go ahead and find the answer to each question. Now, if you turn the page to page 16, you will see 1, 2, 3, 4, 5, 6. 6 problems that you can work on page 16. And then on page 17, there's going to be this one. And this one is going to be kind of the advanced problem. Not the one that I expect you to complete, but challenge yourself. See if you can answer that one too. All right, so let's go through the second one, and we're going to see if we can solve and find those missing lengths. Oh, by the way, here's the try it too. It says, write a proportion that you can solve for PS. So how can we solve for this length? Well, that's the long leg in our right triangle. So I can compare it, or in our medium triangle, I can compare it to the long leg in our small triangle. So let me go ahead and do that. I'm going to compare the long leg in the large triangle, that's PS, and I'm just going to put that on top. PS divided by the long leg in my small triangle. In the small triangle, we found out that that was 12. So PS divided by 12 is equal to, and let me go ahead and look at another side that we know. That's 20 and 15. So why don't we just do that? 20 and 15. We could go ahead and solve for PS. Because it's in the numerator, it's real easy to solve for. We just need to get rid of the 12. Okay, so multiply both sides by 12 times 12 times 12, and we end up with PS is equal to 20 divided by 15 times 12. Now, if you plug that into a calculator, or you just do the multiplication by hand, simplifying by hand, I'm going to do it that way, you'll be able to get the same answer. 12 and 15 are both divisible by 3, so this becomes 5, this becomes 4. 20 and 5 are both divisible by 5, so that becomes 4, and that becomes 1. So ultimately, the denominator becomes 1. We don't care about that, but we just care about the numerators. That's 4 times 4, which is 16. So PS is equal to 16. We created the ratio, and now we solved for it. PS is equal to 16. Problem solved, problem taken care of. So your goal is to make the ratios, really focus on making them. They're hard to make. And then once you've finished making them, you want to solve for the ratios. Now later classes, especially 4th and 6th period, we made a whole bunch of ratios on Friday. You should already have the ratios ready. Now you want to solve. I'm going to give you one example of how to solve for those ratios. And it's right here. So we're given this right triangle, ACB. We want to find the measure of CD. That's this one. If you remember, that's called our height. So I'm going to just put it right there. And I want to create the ratios. Let me double check on the lengths, short leg, long leg. Okay. So if I look at the small triangle, then I know that this is my long leg. And I know that this is my short leg. So I want to create two ratios that compare a short leg and a long leg. Now in my medium triangle, right here, notice how the short leg is H. It's that same one. And then the long leg is right here. So we've got a short leg and a long leg. Let's go ahead and create the ratios that work here. So I'm going to go with my short leg to short leg. That's 3.6. Oh, wrong color. 3.6 to H. That's my two short legs. Okay, and this is my small. This is our medium. Okay, 3.6 to H. And now I'm going to compare that, or set it equal to, the second ratio, because these would produce the same scale factors since they're similar. And so for the small triangle on the long leg, that's another H, and for the large triangle on the long leg, that's 6.4. So now I've got my equation. 3.6 divided by H, that's the short one, and H divided by 6.4, that's the long leg. Got the short and the long legs. And this creates an equation that we need to solve. So we're going to go ahead and multiply 3.6 times 6.4 is equal to h squared. What is 3.6 times 6.4? And by the way, just to make sure we understood how I did that, I cross-multiplied. Multiplied the h's to get h squared. Multiplied the 3.6 and the 6.4. If you remember that cross-multiplication from 6th and 7th grade math, we're using it right here. All right, so I've got 3.6 times 6.4 is equal to h squared. I want to solve for h. So the first thing I'm going to do, before I even multiply these and find out what that answer is, I'm going to get rid of the square root. So I'm going to apply or get rid of the square by applying a square root. Those will cancel, but then I need to do it to this side as well. And I end up with this equation, the square root of 3.6 times 6.4. Using your calculators, you can plug that in. I'm going to use Desmos right here. And let's get it pulled up. There we go. 3.6 times 6.4. 4.8. H is equal to 4.8. All right. So now we know what our length is. 4.8. Now, another thing that you always want to do is kind of check if your answer is reasonable. If this answer didn't give me 4.8, maybe it gave me 48. I would look at this length and I'd be like, that's 3.6, probably not 48. Maybe I did something wrong. This is 6.4. This length has to be shorter than that. So 4.8 is reasonable. But if it was 48, it wouldn't be shorter than that. All right. Go ahead to each of the next problems. Create the ratio. That is by far the biggest thing. I would recommend you take your original triangles, the ones that we cut out and made, write on them lightly like we did on Friday, and then actually make the comparisons. In this set of triangles, if I were to draw them, notice how there's the medium triangle and the small triangle that we're going to compare. Okay, here's the medium one, and here's the small one. So I put those in there. And then if I look at the small one, the small leg is 5, and the large leg for the big one is 15. Okay, and what about the long legs for the medium one and the long leg for the small one? Long leg for the medium one is unknown. It's h. And the long leg is for the small one. And the short leg for the medium one is also h. So this allows me to create this ratio. If I go from small to large, I'd be like h divided by 15. Notice how they're right there. And that equals 5 divided by h. So, just like with the last problem, I need to solve this by cross-multiplying. H squared is equal to 5 times 15. So h is equal to the square root of 5 times 15. All right, what is that? Five times 15. 8.66. 8.66. Now, I could also write it like this, just by typing in 5 times 15 here. This becomes the square root of 75. All right. Now, the square root of 75 is kind of a weird answer, but it's pretty useful because one thing I can do with 75 is I know that there's a square in there. I can factor that square out. It becomes the square root of 25 times the square root of 3. Square root of 25 is 5, so this exact answer is 5 root 3. And its approximate answer is 8.66. So, for those of you who are bold enough to try it, try to solve the equations by simplifying out that square root. We haven't done this in a long time in this class, though. It might be a little difficult. All right. With all of that said, go ahead and use this to solve each of these problems. And then, once you're done, try out the hard problem here. Now, the sub will only be grading you on completing everything in Chapter 16 and trying out something in 17. She'll be checking on that, or she will be checking on that. But test them out. Once you're done, just leave them on your desk. Make sure your calculator's put away. and you've got some free time, but you want to get them done. You want to develop and create these ratios. If you're able to create these ratios, the ratios that we have to do in the next section are going to be very, very easy for us to work with. I hope you have a wonderful day, and I'm sorry I couldn't be there. Have a good day.